All right. I think we're live. All right, so here's Mount Rainier. And so I'm basically going from here to here. So that line, measure that line, distance, properties. So I get 111 miles. And I can measure it manually. I already have it done, but so 111 miles is what it says. So all right, so from the NGS database, they got a point, believe it or not. So if I right click, place an X, loads all the benchmarks. And they actually have one right here, which is SB. I already got it downloaded. Is this one? It was SB, the PID number, SB111, whatever. So for the elevation for that is 14,399. I have to use meters, but and then they have the geoid height. So basically, you subtract 19 from that number, and then I go into to get the ellipsoid height. So of course, it gives me the and they had it was the other one, XYZ. Let me see here. Looking for the coordinates. Oh, right here. Huh. So it gives me the coordinates right there and right here. So with this XYZ with NGS, I downloaded the XYZ win, which I have right here. This guy, and you just put in those numbers and the ellipsoid height, and then I create my text file, which I have right here. I've done a whole bunch of these. So I just need a top and bottom for both points because I'm doing, where's that picture? When you do this, I just need a top and then a bottom. You know, I need to know that line right there for both. And then I can measure this angle. See? Now the drop I didn't know because I don't know the base of the. I mean, I can circle around. I don't know the base of this Mount Rainier. Now for a building, I can do that. I can do the top of the building, like for the Sears Tower, because they got a. Well, I can find the ground, but here I really don't know the ground at the center of this mountain. So I just used 4,000 feet for my base elevation. So I can't get the drop, okay? It will tell me from this distance how much of the mountain I should see, okay? That's what I'm doing here. So I was going to do that other experiment, but and then I come across here and I'm like, well, man, I don't even got hardly, like, you got to have a brain to calculate it. And I just said I couldn't really find a level ground around here to do that, so I just did this one. Why not? Okay, so I got to put there, and then I do have a point for this one too, believe it or not. Well, they have a whole bunch of them. I just picked that one. I'm surprised I got this one. Okay, so let me zoom out to that other location. If I can find it. Yeah, by this like South Bay. Uh, I'll place another X here. And I just picked a random point. Something that had the ellipsoid. See, that other one didn't. So I had it. Yeah, I think I explained it. You subtract the geoid from the ortho, or the height of the mountain. So I think I picked. Which one did I pick? Right on. So the PID is 8H. AH7009. Is that what I got? Is that, no, 8. I use this one. Damn it. Yeah. Okay, so if I zoom in there, and then you can tell, okay, there's a house here, and a little something. Okay, so I got the same thing here in Google Earth, that house, and here's that little deal. You'll see these three little speck, whatever the hell they are. So you know, them three specks right here. So I mean, it's right there. Measure so for my measurement. So it is 111 miles. So I got the. I don't need to click on it because there's no. I can't. Why not? Get data sheet. I already had it, but it tells me the ellipsoid height right there. So. But the ortho height 708. I don't know why I said 19 feet. It's probably because of his meters. No, it says 19 feet. That's in 6 meters for the Earth ortho. That's the elevation. So it is at 20 feet above sea level at that right there, which is almost right next to the ocean. So with that said, we'll close that. We'll close this. And we'll close this. And this is how I do it. So with the XYZ coordinates. So I get the Earth surface. So blah blah blah. So you get the ellipsoid, center of the ellipsoid. You'd have to, if you don't know this, then you'd have to look into it. But this is how it's done. So I'll get rid of that, and we'll go into my drawing. Now I've already got him in there. So like this is 2 scale. So if I go to realistic, I have the ellipsoid and the perfect circle. So you'll see 2 different, like blue is the perfect circle. So that's the ellipsoid is wider at the equator and narrower at the poles. So that's why you'll see blue. If I zoom in here, the red will just disappear. If I reach in. See? Now if I go to the equator, then it will be the red. And the blue would disappear. See? Alright. So I placed them in there. I created my points, my tops and bottoms. So here is the lake or the ocean. And that other point is the mountain. and it places it. The origin point is how this works. Is like the center is 0, 0, 0. So that's the origin point, and so then it places it right on the globe. It's awesome. So I can see them right there. Right here. Just barely, just like sticking out like needles. Well, the mountain's kind of tall, so it's going to stick out. See? But the other point won't. So, that distance ain't hardly anything compared to the size of the Earth. Alright, so I'll tell you how I got my -2 degrees. Looking from, if I'm on top of that mountain, I can't really do it the other way because the base, I don't know what the base is at the center of the mountain, so I can't tell you the drop. Okay, so I don't know. Yeah, I can draw it, just draw a circle and blow it, do it that way, but I'm doing it from this standpoint because this is the way it's correctly done. So this is the equator, and so I draw these lines. I got rid of it. I draw a line. That's why I got two. I got top and bottom. Like I just made a point. So I have a straight line, so I can project that line down to the center of the Earth, and then I draw this line, which is the ocean, straight down to the equator. So if I check, and this will give me the latitude for that. So, like if I did it right now, it's pretty cool. So I know it's the green line because I made it green. So I know the difference. The white one's the mountain. So if I go NEA from here to here, and then NEA to here, and then measure that angle. I guarantee you, I haven't done it, but I guarantee you, it will measure the latitude. So I got 45 or 4650. I don't know if you can see it. 4650, 58. So let me come over here to this. That's what they called it. And we'll expand this. And the northing is right here, which is the north latitude, and it's 4650, 58. And I got 4650, 58. 46, 50, 50, same thing. Pretty awesome. Okay. And it does it with the latitude also. Okay. So that's how that works. Now, how do I find the this angle here? I need to know, how do I find this delta elevation? If I'm looking here, actually I'm taking this tangent line, this horizontal plane, I'm going to make it goes across here. And I'm diving down. And I measure that angle right here. This is from Jesse, so from a different project. And I did his numbers, and I came out with pretty much the same thing he did. So I want to check. Oh, and I'll check that line. So I drew a line from point to point. So here's the base, which is, I said it was 4,000 feet. So that line right there is the height of the mountain, what I think. Well, that's the tip of 14,399, but I don't know what the base is. It could be 3,000 above sea level. I don't know. I just chose 4,000. But that line is a long ways. So my drawings in meters. Oh. Trying to make this fast, but with CAD it's hard to do that. Feet, meters to feet. Paste. So I got 10,398. Which is correct. If you take that minus 4,000, or I don't figure it out. You got to get down to 0 at elevation. So, so if I added that, copy, if I paste that number plus 4,000 for the elevation equals 14,300. We'll call that 99, just like the data sheet says. So, because it has that right there, 14,399. And the true elevation is 14,411. So that I'm whatever. So, okay. So, is how I get the tangent. Oh, I'm going to measure that line from the base to there. Actually, it's the chord. But I don't need to do an arc distance because the chord, it's not going to be my, the arc distance is pretty much the same as the chord because it's not that far away. If I was doing 1,000 miles, probably I would want to do an arc. So the length of that line in meters is that, We do convert meters to miles. Paste. So I get 111. Same thing Google Earth got. So I know the point's right. Okay. So now, get my tangent line here. So 3-point NEA. That line goes to the center of the Earth. So I hit that. And then it's top of the mountain. I hit that. And then this line goes to the equator. And I hit that. Now I draw a line. We'll make it a different color. We'll make it green. We can see it. Okay. Now it will draw two lines. See, one going off that way and one going that way. Well, I've already done this, so I know it's not that one. It's this one. Okay. So then I need to redo my ECS to that line. NEA. From here. And then to NEA to that line. Bam. Now if I measure it, I'll bet you $100 it says 90 degrees. From here to here. 90 degrees. Okay. So then I set my view. That's how, with this guy here, I hit the top. Okay. It'll set me to that view. I'll rotate it because I want north. Now up. Okay, so here's my tangent line I just drew. Okay. So I can tell you the drop there, which it didn't really match with Google Maps. Normally it does. And then I draw a line from here to the ground, to there. And then I measure it. So I got I'm in degrees, minutes, and seconds. We'll change this to decimal. So just 2.21. But my drop, you can't really do it that way. It doesn't work. Anyways, that's what I get. So if I reverse it, we'll go the other. I can tell you how much of the mountain you'll see. So we'll reverse it here. So I can't tell you the drop because I don't know really the base of the center of the mountain. So I'll just do it the opposite way now. the ground of the ocean. Well, kind of. And it's 20 feet above. Maybe it has a large wave. Maybe an NEA to that line. I'll draw a line. And once again, I know it's not going that way. I know it's this one. Okay. Reset it and redo my UCS to that line. NEA. And then to this line. It'll say bottom. I'll hit that bottom. Bam. Now, along that tangent line, which is this one right here, that's what I'm drawing right here. I can't tell you the drop, but I can tell you what's above it. Because I don't know what the ground is. Okay, so if I draw a line from here, perpendicular to that line. I'll zero these out, the Z's, or that one. Yeah, you gotta do that on when you do this. On the other one, you know. So there's my distance. So from standing at that point, you should see my convert. Meters to feet. You will see 6,000 feet. That's a mile. So 6,000 feet, and the thing is 14,399. So you will see a little half 7, so I'm not quite to 7. Just a little under half of the mountain. Guarantee you. So, and I know that's right. Has to be. You won't see the whole mountain, I guarantee you that. But you will see at least a good portion of it. Half of it almost. So, I'm going to close there.